In this video, we're going to do a numerical example for calculating the capacitance of a parallel plate capacitor. And so to set things up, let's say that the width is equal to 1 centimeter, and this is a square capacitor, so the width is the same on each side. And let's say that the distance, the separation between the plates, is 1 millimeter, and the material inside the plates is free space. So this material inside is just free space. What is the capacitance? So because this is a parallel plate capacitor, we have an approximate formula for the capacitance, and that is equal to the permittivity of the material inside the capacitor multiplied by the area of the capacitor, all divided by the distance or the separation between the two plates. So all we need to do is figure out what each of these quantities is and then plug everything in. So we know that the permittivity, epsilon, is just the permittivity of free space, or epsilon naught, because the material between our capacitors is free space. And this is about 8.85 times 10 to the minus 12 farads per meter. Now, you might have seen epsilon naught in terms of newtons per coulomb. It turns out that the units are also another set of units that represents epsilon naught is farads per meter, which happens to be convenient because capacitance is in units of farads. So that's one down. Now, how about our area? Well, in this case, we don't have the area directly, but we do have the width of the capacitor. And so I know the area of a square is just the width squared. And so if we wanted to figure out what the area is, all we need to do is square 1 centimeter. Now, in this case, to make our lives easy, I'm going to put everything in SI units. So I want everything to be in meters, farads. If we had kilograms, we'd want kilograms. So I'm going to first convert this width into meters. And I know that the 1 centimeter, if I multiply by 1 meter over 100 centimeters, because there's 100 centimeters in each meter, then this is equal to 0.01 meters, or 10 to the minus 2 meters. So I prefer to work with scientific notation, especially when we're squaring stuff and dividing things. So we've got 10 to the minus 2 meters all squared. And if we squaring this, we only have to multiply this exponent by 2. So this becomes 10 to the minus 4 square meters. Now the only thing left is distance between the plates. And so we know that it's equal to 1 millimeter. But again, we want everything in SI units. So I want to put this in terms of meters. And to do that, I need to multiply by 1 meter divided by the number of millimeters in a meter, or 1,000 millimeters. And this is 0.001, or 10 to the minus 3 meters. So we have all of our quantities and they're all in SI units. So finally we can plug everything in. So permittivity, about 8.85 times 10 to the minus 12 farads per meter. And then we multiply by area, which is 10 to the minus 4 meters squared. And then on the bottom, we have 10 to the minus 3 meters. Now, the first thing we should do is make sure that our units cancel. So we've got one of these meters cancels with this meter, and the other meter cancels with the bottom one. So we're only left with farads, which is what we want. The farad is the unit of capacitance. Now, you can plug this into your calculator, but I personally recommend that you only plug in the sort of somewhat irregular numbers. So if we had, a 1.5 on the bottom, for example, then I would plug that into your calculator. But so what I do when I solve these problems is I bring all the weird numbers out front. So in this case, I would call 8.85 a weird number. And then I leave all of the 10 to the minus stuff on the right. So we've got a 10 to the minus 12. We've got a 10 to the minus 4. And then all that divided by 10 to the minus 3. And the units of this. Now on the right, this is much easier to simplify because we can just subtract and add numbers rather than plugging everything into our calculator. And so 10 to the minus 12 times 10 to the minus 4 is 10 to the minus 16, because negative 12 minus 4 is 16. And then 10 to the minus 16 over 10 to the minus 3 is minus 16 plus 3, or 10 to the minus 13. 10 to the minus 13. So this is our answer. 8.85 times 10 to the minus 13 farads. Finally, I'd like to thank all my patrons on Patreon. Your support is greatly appreciated, and it is you who makes these videos possible. If you aren't currently a patron, to get early video access, behind-the-scenes footage, exclusive content, and join a like-minded community, click the link on screen or in the description below. Thanks for watching.